Hello, this is a video tutorial on adjacency list representation of a graph, which looks like this one. We are going to see the way to implement breadth first search of this graph, which is represented in adjacency list in this way. And this is part of a program which may insert H-nodes into this graph. And we are going to see the complete program that may form such adjacency list of such a graph. And let's see that code. Okay, as we have seen in the class, this is a class that is going to implement this graph. This is a class that is going to implement the graph we are talking about. And this is a variable that determines the size of the graph or the node. And this is, we can say this is a variable which is going to create this one, the number of nodes that we are going to deal with. Okay, this is a variable which is going to determine the size of the node, which is this. How many nodes do we have? Totally 7. 0 to 6, that is totally 7. Okay, this is initialization. Actually, this is declaration, and then there is initialization here. Just I will show you. Anyway, this is a constructor which is going to create the node. This is the constructor, and this is the function that is going to insert each node in the form of undirected list, undirected graph. This is a function that's going to insert each node in the form of undirected graph, and this is the function that's going to implement breadth first search. It displays the whole graph, which is this one, in the form of breadth first search. Okay, let's see the constructor. This right arrow v equals to v means this v equals the value that comes as a parameter from this. So as to form a graph or to determine the size of the graph, the user should have to pass some number as a parameter of this constructor, and then that number determines the size of the node. And adjacent adg, which is this variable, equals new list of type integer of the size v, which is this one. So this creates what? It creates this one. It creates this list with no, okay, it creates this list. First, this list is the one just I'm moving. It creates this list. Oh no, sorry. Okay, it creates this list, the one I'm moving. This list, the one I'm moving, is created with the code that I've shown you. Okay, it's better I do this one. Okay, you see this? This is the one I have just highlighted is created with what? It's created with this. We create with this. Okay. Okay, and then let me return this one. Okay, this is okay. Yeah, that's it. Anyway, this part is created using the code I've shown you. And what does this function do? Of course, this is what we have already discussed in the class, but to remind you what it is, This function takes the initial node and the destination node, and then it connects both of them. For example, once you pass here 0, then 1, 0, 1, what this function do is it connects 0 with 1 adjacent of u pushback what b, that is 0 pushback 1, that is 0 is connected to 1. To make it undirected graph, again what we do is we reverse this connection, that is adjacent of v pushback u. So writing these two at the same time may create undirected graph. What if I just remove this one? This is directed graph that connects 0 with 1 only. The direction of the graph is only from 0 to 1. 0 has child 1, but 1 is not child of 0. So these two lines makes connection two-side, which results in undirected graph. Okay, my main topic that I want to cover in this video is not about the whole this. I want to just emphasize on this function. I want to emphasize on this bridge first search function. I want to just discuss with you in detail about this function. Okay, sorry. Okay, let's see what this function does. I wish I'll just minimize the font so that you can see the whole thing. So look at this function now. Yeah, let's see this function, bridge first search. How does it display in bridge first search? Bridge first search is a search or mechanism of displaying a graph in bridge technique, that is horizontal. The display takes place horizontal wise, that is like this. Let me show you. Display takes place okay, in what direction? Okay, here first it displays this the parent, and then the child, and then the next child, and then at the last it displays this one. It displays horizontal. It takes priority for horizontal display. 0, 1, 2, 3, 4, 4, 5. This is what we call bridge first search. Bridge first search. This is what we call bridge first search. What if in case of depth first search, the way it displays it first is it displays 0 if the starting point is 0, and then 1, and then 3, and then 5, then 6, 4, 3. So first it gives priority for depth wise, and then to the horizontal side. First it finishes the depth, and the rest is displayed next in case of depth first search. Okay, this is bridge first search, therefore it should have to be displayed in this way. Okay, here first of all, what we have to do is our starting point from which we are going to display is should have to start from this location. The user should have to pass the starting node from which we are going to display. In our case, that starts from 0. Starts from 0. It starts from 0. Therefore, how does it display? It starts from 0. Okay, starting from 0. Anyway, first of all, this function creates an array with the name visited whose data type is boolean. Why this is used for? We want to just check this array checks whether the given number is visited or not. Once it is visited, it assigns number 1. If it is unvisited, it assigns 0 to imply that it is not visited. Anyway, for the first time, every node is unvisited. Therefore, we declare an array of size v, which is equal to the number of nodes, and then we make all of them what? False. That is what I want to say is here. Okay. What I want to say is, for the first time, every node is unvisited. And let me remove this first. Okay. Let me remove this. Every node is unvisited for the first time. Okay, this is here. Let me just move it one step back downward. Okay, for the first time, everything is unvisited. Okay, here. Okay. Everything is unvisited for the first time. So we have created an array of the size equals to the total number of nodes, and then we make every node unvisited. That is, have to make 0. Every node is unvisited for the first time. So as unvisited, false means that is 0. As unvisited, what the main target of this program is just to display this node, this graph in breadth first search way. Okay, we have made everything false, which is 0. Then we create a queue. That is this one. We create a queue. For what reason do we use a queue? We use a queue so as to display the given graph in breadth first search way. So it gives us a guarantee of displaying the graph in breadth first search way. In case of depth first search, we have to use a queue. We have to use stack. For this purpose, we have to use queue. Therefore, we create a queue, and then we store a number from which we are going to start to display the whole graph. To display the whole this graph in breadth first search way, we have to have the starting number from which we should start, and that is in our case that is 0. G dot bfs of 0 means just start displaying the graph in breadth first search way starting from 0. Therefore, that number is stored for the first time on what? On queue. We store it in. We have made everything unvisited, and then the starting node should have to be stored, or the starting number should have to be stored on the what? On the queue here. That is 0 is stored on queue. Then what's next? And then don't forget that every number, once it is stored in the queue, immediately should have to be visited. We have to assign a number which tells that it is visited. So any number entering to the queue immediately should have to be visited, because 0 is inside the queue. It's visited. I have to assign 1. 1 means 0, which is this 0, which is this number, is visited. Anyway, visited number shouldn't be visited for the second time. This is the criteria. Therefore, we have made 0 visited. The rest of the task is done inside this while loop. This while loop does everything that's remaining. So, is the queue empty currently? No. key is not empty. So what we have to do is we have to take a data from the front part and store it on S. There is one number which is 0 inside the queue, so queue is not empty, and take that front number which is 0 and assign it on S. So that is, take what is found on the front side of the queue to the S, that is 0. 0 is assigned for S, and then what? And then pop front. Once you take that number and assign to S, immediately delete from the queue. It shouldn't exist there. So I pop it. What's next? Once you pop it, immediately display. So display starts here. We have to display cout. Cout. What's next? Next is we have to create pointer like variable and then find adjacent of the number which we have been talking about, that is 0. Create a pointer I, which is iterator. Iterator is a variable which is going to start searching an adjacent of the number 0, currently the node that we are talking about. So this iterative variable does this inside the for loop. It finds all adjacent of 0 which are unvisited, and then once we get them, we have to put inside the queue and make visited. I told you before that any number that is put inside the queue should have to be visited. We have to assign, we have to tell to the boolean type visited that number is visited. Anything inside the queue should have to be approved that it is visited. Okay, so this iterative variables makes here I equals adjacent of 0. So we are talking about 0. What? I equals adjacent of 0 dot begin and then I is different from adjacent of 0 int, then I plus plus. From the starting adjacent of 0 up to the end, we have to search, and if it's unvisited, this note says if it's unvisited, just put inside the queue and make it visited. So to do this, what is adjacent of 0? What's adjacent of 0? Adjacent of 0 is 1 and 2. Look at adjacent of 0 is 1 and 2. Here in adjacency list, it's represented like this. Adjacent of 0 is 1 and 2. So adjacent of 0 is 1 and 2, but we have to consider only the one that is unvisited. So 1 and 2, both of them are unvisited. So what we have to do is first put both of them inside the queue. The one which is put first inside the queue is the first one, first adjacent of 0. Which one is first adjacent of 0? 1. 1, 2. Adjacent of 0 begin means that is 0. Adjacent of 0 end is something outside. End means okay, this is the beginning, this is the second adjacent. Adjacent of 0 end is here, outside 2. Assume this pointer, let me do this. Okay, assume there is a pointer I first starts from adjacent of 0. Begin adjacent of 0 begin, it starts from this adjacent of 0 begin, it starts from adjacent of 0 begin means that's immediately this number. Adjacent of 0 begin is the first adjacent of this. The second adjacent of 0 is this one, 2, and adjacent of 0 end is just here, outside adjacent of 0. So until it is different from adjacent of 0 end, it searches one by one. Once we get any unvisited adjacent of 0, we have to put inside the queue. Okay, first this I iterator finds adjacent of 0 begin, which is 1. Is 1 unvisited? We have to check. Is 1 unvisited? Visited at this. Is 1 unvisited? Yes, it is unvisited. So what we make is we put inside the queue and then make it visited. So 1 is put inside the queue and then we make it visited. So look at this one. We make it visited. That is 1. First we put inside the queue and then we make this variable, which is this node, visited. Visited means 1. Unvisited means 0. The unvisited nodes are this one, 2, 3, 4, 5, 6, 8. Anyway, what's next? I increments to where? I increments to this location. And I is different from adjacent of 0 int. Therefore, we go inside and is visited at star I true. Is it true? That means is 2 unvisited. Is this unvisited? Is this one unvisited? Yes, it's unvisited because here on visited variable 2 is what? Unvisited. So what we make it is first we put inside the queue and then we make it visited. So first we have to put it inside the queue. So 2 and then we make it visited. That is, this is police. Okay. 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 Anyway, we make this one. Once we put inside the queue, we have to make it immediately visited. Visited means that's one. Okay, we have put inside the queue. Adjacent of 0 is put inside the queue. Then what's next? We go to the while loop. Is the queue empty? No, just stored on S from the front part. Is the queue empty? It's not empty. From the front part, just store on S, that is 0 is replaced with 1. 0 is replaced with 1. And then when we pop from the queue, once we store on S, just pop it. That is just remove from the queue. We pop it and then we display. And we display what? 1. We display 1. What's next? Once we display, we have to find, using iterator variable, we have to find adjacent of 1 which are unvisited. What are adjacent of 1 which are unvisited? So adjacent of 1, look at adjacent of 1 which is unvisited is what? 3. First of all, what's adjacent of 1? Adjacent of 1 is 0 and 3. Look at 0 and 3 are adjacent of 1. But we want only the unvisited 1. Adjacent of 0 is 0 and 3. Therefore, 0 and 3. But only 3 is unvisited. Therefore, we put only 3 inside the queue. We put it inside the queue and then make it visited. So I put 3 inside the queue and then I make it visited. 3 is visited already. Okay. 3 is visited. What's next? Again, we go to the while loop. from the front part, just store on S. So 2 is from the front, from the queue, from the front I store 2 on S, that is 2, and then I do what? I pop it, I remove it from the queue. 2 is removed from the queue, and then what? I display it, and that is, I have to display it 2, and then what? I have to find adjacent of 2. Okay, here adjacent of 2 which are unvisited. Adjacent of 2 which are unvisited. What are adjacent of 2? Adjacent of 2 are 0, 3, and 4. 0, 3, 4. Look at 0, 3, 4. But only 4 is unvisited. Therefore, I put only 4 inside the queue and make it visited. 4 here, and then I make 4 unvisited. This one, that is 4 is visited. So 4 is visited. So what's next? I go to the while loop. I go to the while loop. Is QMPT? No, just take from the front and store on S. That is 3 is stored on S. That is 3 is stored on S, and then we pop 3 from the queue. We pop it from the queue, and then we display. And then we display what? 3. And then what's next? We find adjacent of 3 which are unvisited. Adjacent of 3 which are unvisited. Adjacent of 3 which are unvisited are what? Adjacent of 3 are 1, 2, and 5. 1, 2, 5 are adjacent of 3. 1, 2, 5. But only 5 is unvisited. Therefore, I insert only 5 inside the queue. And only insert 5 inside the queue which is unvisited. And then make it visited, which is okay, I make it visited. What's next? I go to the queue, while loop, and then take front element on S, which is 4, and then remove it from the queue, and then display this according to the, I take it, I store on S4, I pop it from the queue, and then I display it, which is, I display it here. What's next? I have to find adjacent of 4 which are unvisited. Adjacent of 4 which are unvisited. Okay, adjacent of 4 are what? 2, 5, and 6. 2, 5, and 6. 2, 5, and 6. Only 6 is unvisited. Therefore, 6 is inserted inside the queue. 6 is inserted inside the queue, and we make 6 visited. Okay. We make it visited. Then what's next? Is the while loop empty? S not empty. Just store front element on S. Front element on S, which is 5, and then pop 5 according to the code, then pop it, because store on S, and then pop, then display that number, and then display that number, which is 5, and then 5 adjacent of 5 which are unvisited. Is any adjacent of 5 which are unvisited? Adjacent of 5 are 3, 4. 3 and 4 are visited, therefore nothing to store inside the queue. Therefore we go to the while loop again and take the front element on S. Take the front element on S, which is 6, which is okay. Okay. Which is 6 front element, and then once we store on S, we have to just pop. We have to just pop from the queue, and then we have to display according to code. We have to display, and we have to display here. We have to display, and then we have to find adjacent of 6 which are unvisited. Once we display, we have to find adjacent of 6 which are unvisited. So here adjacent of 6, adjacent of 6 which are unvisited. So what are adjacent of 6 which are unvisited? Adjacent of 6 is 4, and 4 is already visited. We have nothing to insert inside the queue because everything which is adjacent to 6 are already visited. Therefore, we don't insert anything inside the queue. So we go to the while loop. Is the queue empty? Is it empty? Yes, it is empty. That is, once the queue is empty, we have already finalized that Breeze first search is complete. Already we have completed displaying the given graph in Breeze first search technique. So queue is empty means we have already completed displaying in BFS way. Anyway, let's see. Is it really true? Can we really prove that it is displayed in Breeze first search way? We can just check using this. First, it displayed 0, then what? 0, then 1, 2, yes? 1, 2, 1, 2, then 3, 4. Look up. 3, 4. And then what? 5, 6. Yes. Bridge means horizontal. Bridge means, what does bridge means? Bridge means that is bridge. Bridge means that is equivalent to horizontal. Horizontal. Okay. Horizontal. That is Breeze first search technique means displaying in horizontal way. So we have display horizontally 0, 1, 2, 3, 4, 5, 6. That's it. Okay, one thing that every one of you should remember is the display technique, is the displaying mechanism the same if these two numbers exchange? For example, like is it the same if this is 1 and 2 and if we reverse these two? 2 here, 2, and then here 1. Is it the same? It's not the same. That is not the same. Don't consider that this is the same. We will see the difference here. let me make this one exactly the same as the previous one. Just doing this, that is 1 here, 1, and then here 2. First of all, let me display this one. Let me display this using bridge versus technique. Okay, here not 0, actually this is U, this is B. There is something wrong of me, that's I. not I, S. Here is S. Okay, look at the way we have displayed. Look at 0 first, then 1 2, then 3 4, then 5 6, 0 1 2 3 4 5 6. That's right, that's right. Okay, let's exchange these two numbers. That is okay, here is 2 2, and here is 1. Is it the same? Okay, this can be done only if you just edit this one. If you just edit this one, let's see these numbers the way it's already done. Look at previously it was connected like this. 0 was previously, this is 0, which is 0, this is 2 previous, no, this is 1 1, this is 2. How? G dot are each 0 1. Immediately to 0 1 is connected first, and then in second G dot are each 0 2. After connecting 1 to 0, then we have connected 2 to 0. First immediate child to 0 is 1, and then next one, what is connected? 2. So the connection step matters in displaying in bridge first search way. If you connect 1 then 2, then whenever we display, then 1 first comes and then 2 comes second. What if we exchange these two? Okay, in case of this, just we have got this result. We have got this result, which is 1 2 3 4 5 6. But if we reverse these two numbers, like first if we connect to 0, first if we connect 2 and then 1, that is this changes to first we connect 2 and then we connect 1. 1 here is 2. First if we connect okay, if we connect 2, that is first we connected to 0 what? 2, and then we connected 1 1. So the first adjacent of 0 is 2, and then so the beginning adjacent of 0 is 2, and the second adjacent of 0 is 1. First this for loop, first look at this for loop adjacent of, whenever we search adjacent of 0, this I variable first gets 2 rather than 1. This is adjacent of 0 begin is 2, and then adjacent of 0 next step is I. Whenever I increments in second step, it gets this one. Adjacent of 0 end means outside this. After 1, the place after 1 is just adjacent of 0 end. Anyway, look at whenever we display this one, the result differs because of this, because of the way I have attached. Okay, let me because I connected 2 to 0 first, and then 1 to 0 in second step, therefore the display differs. So let me make this one S and then make this S, and let's see the result. You see, this is adjacent of 0, begin is 2, adjacent of 0 next to begin, then this is found. So the step in which it displays differs, but still that is breadth first search display technique. This is breadth first search display technique. The reason why this differs is because of the step in which these two numbers are connected to 0. The same is true for the rest of these numbers. If you exchange these two, numbers, again these two reversed. 4 rather than 3 4, it may become 3 4 if you reverse this in inserting the given node. Okay, like look at 2 what's connect to 2, we connect 3 to 2, we connect 4. What if we exchange these two numbers? If we exchange these two numbers, like if I just do it like this, I connected 4 to 2 first, and then I connected 3 to 2 second. So instead of 2 3 4, the sequence will be 2 4 3, 2 4 3, and then if I display the step in which it displays reverse. So once I run this, the step in which it displays will reverse. Still, that is breadth first search technique. Let's see this one. Look at, I exchanged these two, and then the step in which it is displayed is 0 to 1. I exchanged these two numbers in the code, and then the step in which it is displayed is 2 4 3. Why not 3 4? Because first to 2 what is connected? 4. Then next to 4 3 is connected to 2. Therefore this is reversed. So if I just return this one to the previous step, this will be like this. It will come to the previous step. Okay, if I just return it to the previous step, or okay, then I mean previously the step in which it was connected is 2 3 2 3, and then 2 4 2 3 2 4, and then previously 0 was connected not to 2 first, but it was connected to 1 first. Therefore I have to just write this one to the previous step. So cut, and then this first 0 is connected to 1, and then 0 is connected to 2. Therefore this is should have to be to the step to which it was before. So here is please. Okay, here is 2, here is 1. So here is 1. Therefore, so this is the step in which previously it was connected to. So we will see the previous result, which is this one: 0 1 2 3 4 5 6. That's it. That is breadth first search displaying technique. Thank you so much. And in next tutorial I'll show you how to display depth first search in this way. Anyway, thanks so much.